As you probably know, every subject in IB has something called an internal assessment, or an IA, which is an assessment that's worth around 20% of your final grade in said subject. For IB physics, the IA is a 3,000 word lab report where you conduct an experiment of your choosing, which is of course related to physics, to demonstrate your ability to investigate scientific concepts. Although the IA might seem like too much effort and insignificant compared to the 80% exams, that is not the case, as the IA can literally make or break your grade. Let's start by taking a look at this sample level 7 physics IA to get a general feeling for the formatting. There are a lot of parts to your physics IA, the first of which is the research question, which is the foundation of your whole IA, identifying what relationship and physical phenomena you are trying to explore. After your research question, we have the introduction, which expands upon your research question. Here, you should include some history and practical applications of your project. Like, for example, in this IA, the student was studying electromagnets. So they described some basic history of electromagnetism and some real world areas where electromagnets are being used to better the lives of people. After the introduction, we have the background theory section, which, as the name suggests, is where you should introduce any relevant concepts and formulas that you will be using throughout your IA, in addition to your hypothesis, which is basically an educated guess of what you think will happen. To make a good physics IA, you should provide mathematical proof for your hypothesis, as the student has done here. In addition, any other relevant background theory goes here. Like, for example, in this physics IA, the student built their own device for measuring the strength of the electromagnet. So they describe the principles of how their device operates. Moving on, we have the variables section, and in this section, you must indicate and categorize all of your variables into three distinct groups. The first is the independent variable, or the variable that you are changing and adjusting throughout your experiment. In the example of this IA, the independent variable is the voltage that is being applied on the electromagnet. The second type of variable is the dependent variable, which is the variable which is affected by the changes in the independent variable. So it's basically the variable that changes along with the independent variable. And in the context of this IA, it is the magnetic field strength of the electromagnet. Now, it is really important to consider that you should only have one dependent variable, as if you have of more than one dependent variable, then it'll greatly mess up your results and you won't be able to really study any specific phenomena. So basically you should be focusing on studying only one variable. Meanwhile, all of the other variables which could have an effect on the dependent variable are considered control variables. These variables are kept constant throughout the entirety of the experiment so that they don't interfere with your results. Because in the example of this IA, there are multiple factors affecting the strength of an electromagnet other than the voltage applied onto it. So these captive factors are kept constant to remove interference. The next section of the IA is the materials section, which is a short list indicating all the materials needed to conduct your experiment. Note that you also need to include the apparatus section right below the materials section, which will show all of the tools and equipment that you used in your experiment. After your materials section, you have your theoretical error propagation, which is where you do some research and calculations to determine the theoretical uncertainties of your experiment. If, for example, you are using a ruler to measure something, you would state its uncertainty here. This section is really important since the uncertainties you calculate here will be used throughout the entirety of your IA. Also note that your uncertainty should only have one significant figure or one non-zero digit. Moving on, all of these previous sections lead up to the methods section, which is the section where you indicate what you did to collect your data in a step by step process. Note that you can split this section up into multiple sections if you're, for example, building something before starting your experiment, like this student has, since they built their own equipment and it technically wasn't part of their data collection. So they made a separate section in their methodology to describe how they built it. Also note when doing this section, the wording and formatting matters a lot. The procedure should be easy to understand and follow, so anyone with minimum experience will be able to repeat your experiment. Also be sure to include images and diagrams like this student has, as it would make your process easier to visualize and you won't have to spend as much time and words describing the whole setup in intricate detail. And this is really important. You should also use specific values in your procedure. For example, in this experiment, the student used a specific number of batteries with a specific voltage and a very specifically designed electromagnet, and the specific properties of which have been listed in the procedure. Using specific values will make sure that overall everybody will be able to build the exact setup as you if they were verifying your results. Now, this doesn't apply to everyone, but after you're done describing the method, you can talk about two things if they apply to your experiment. For example, if there are any environmental or safety hazards involved in your experiments, you should indicate what steps you took to minimize those risks. For example, since this student was doing an IA on electricity, we talked about how they minimized the risks of electrocution and how they ethically dispose of their materials. In addition, the other thing you might want to include is a preliminary trial section. In this section, you should describe if you had any other experimental setups. For example, in the case with this IA, the student first used another experimental setup to get their data. Still, it failed and they had to change it, designing a totally new system. It's important to talk about this because the evaluators also want to see how you overcame obstacles in your IA, which demonstrates your ability to problem solve. After you have done all of this, you can start the next half of your IA, which is where you'll be processing your raw data and getting conclusions from it. You first should start by indicating your raw data, which is the data that you collected directly from your experiment, and this data has not been altered in any way, shape, or form. You put your raw data into a giant table like so. Note that the table should be clear and easy to read because it will improve the flow of your IA, which is important if you want to get a level 6 or a level 7. Also note, I probably should have mentioned this, but when you're doing your experiment, you need at least 5 data points or 5 different values for your independent variables so you can confirm the exact relationship between your dependent and independent variables. Like, is it a linear relationship or a quadratic relationship, etc. Also, for each value, you should repeat the experiment at least 5 times so that you can average out your results and eliminate any random uncertainties by doing this. As realistically, in the context of this IA, it is almost impossible to eliminate all random errors and uncertainties, so this will generally improve the accuracy of your data. After that, you should include a section where you process your raw data. By averaging out your trials, calculating the experimental uncertainty, as well if you are converting any units, you should indicate the process of that here. So let's take a look at how the student did it in this example. They first started off by calculating their experimental uncertainty and compared it to the theoretical uncertainty calculated in the earlier parts of the IA. Just if you're wondering, you calculate the experimental uncertainty by taking the max value and the min value from your 5 trials and putting them into this formula right here. Note that if your experimental uncertainty is larger than your theoretical uncertainty, which is usually the case, then you should use the experimental uncertainties for the remainder of your IA. You should also state this exact information briefly as seen in this sentence. Next, this part talks about and shows the averages of all the data points, where you calculate the averages for all the data points using your five trials. This is also where you input your uncertainties right next to your data points. When doing this, make sure that your uncertainties and data points have the same amount of decimal places. This is just one of IB's requirements. For most IAs, this is where the data processing section will end, but for some IAs like this one, the student had to convert a voltage reading to a magnetic field strength reading using a formula, because that's what they're trying to find in their IA. So that also goes in here. Next, we move on to the graph and analysis section. In this section, you take your process data table and plot it onto a graph. Like this, you can use Desmos for it as it is a great tool for this kind of stuff. Anyways, your graph should have the following: a title which should indicate which values you're plotting, the title of your axis which should indicate the units that you're comparing. Note that you want to plot the independent variable on the x-axis and the dependent variable on the y-axis. As well, you must plot three different lines. The first line is the line of best fit, which, as the name suggests should correctly model the points. Note that the relationship should also be linear and intersect the origin. If it is not linear, you must linearize your graph. I'll probably attach a video how to do that below. You should also have two other lines, like this blue and red line, which are the min and max lines. They are the lines that basically show the maximum possible slope and the minimum slopes that you can possibly get from this relationship. And to do this, you basically use your uncertainties for modeling the lines rather than the actual points themselves. Also, note that these lines do not have to intersect the origin at all. Now, moving on, after you got your graph looking something like this, you should be analyzing it below. Talk about the linear regression of the points and why or why not the model works. You may also want to find some unknown variables using this model, like this student has done so here. You will also want to find the uncertainty of the gradient using these formulas. Then, at the end, you should accept or reject the results that you received. Also, it is important to note that your experiment does not need to succeed fully, and as long as you prove the relationship between the variables, you should be good. After that, we have the conclusion. In the conclusion, you should reflect upon your results further. You can start by summarizing your graphical results, like state the linear regression, the uncertainty of the slope, etc. You should also consider other models and not eliminate the possibility of these other models being applicable to your data. You should also suggest why or why not they should actually be properly considered. And you should state if your hypothesis was correct, since that is the whole point of your IA. And if it was incorrect, you should discuss why that is, what factors could have led to that, whether it was some random or experimental uncertainties that led to this. Lastly, we have the evaluation. The evaluation section is the second last section right before the works cited. In this section, you're evaluating your experiment, discussing what went well and the limitations of the experiment. To start this section off, you should start by talking about the positives. Like, for example, despite the fact that this IA did not produce accurate results, the students still talked about how the experiment was very precise, since the uncertainty was only 5%, which was very good since the materials used in the experiment costs less than $50, which is very cheap considering that professional Gauss meters cost hundreds of dollars. The student also talked about how safe the experiment was and how many precautions were taken to ensure the safety of the lab, which is a huge benefit. Now, your second part of your evaluation section must discuss the limitations of the experiment, or the parts of your experiment that cause unnecessary uncertainties. Note that your evaluation addresses an entire 6 mark section of your rubric, and it is physically impossible to get anything above 3 marks in this section if you don't have any limitations. Now, moving on, you can and should use a table to organize and list out all of your limitations, just as you can see in this example. It'll just make it easier to follow. Your table should indicate three things. The first is the limitation itself, which is the problem in your experiment that created or could have created an uncertainty. The second part then should discuss the impact of this limitation on the experiment. And then you should address and discuss how you can improve and potentially eliminate this source of error. So, for example, the student indicated that their home built Gauss meter was a major source of uncertainty. Then they described that it used a lot of parts which had pretty high uncertainties, which is why it had such a huge impact on the experiment. The student then indicated a possible solution, that being getting a store-bought Gauss meter, since unlike their DIY device, a factory-built Gauss meter would be better build quality and would have a smaller uncertainty as a result of that. Once you've done your evaluation, you're basically done. All you have to do is the references and appendixes section. The references are pretty standard. You should do it in APA, of course, and all of your miscellaneous calculations go into the appendix. And after that, you're done your whole IA.